Good morning, Algebra 2. Today we are going to move on to different topics from what we have been doing before, which were polynomial functions and such. So from this point onwards, we are not going to take a look at end behaviors and sketching, based on the zeros, but rather we are going to concentrate on a couple of more new vocabularies that I'll introduce you for today. And so today we are basically going to just go over the basics of rational functions and how to sketch, if you can, at the end of this video. So first, I want to talk to you guys about what are rational functions from the get-go. The rational functions here, it means that any decimals or numbers that can be represented as fractions are called rational numbers. So when we say something is irrational, it means that the number cannot be represented by a fraction. That's all you have to remember. So these are a couple of examples of what we call rational functions. As you can see, you will have a numerator and a denominator portion. And most of the time, they will contain x in the numerator and denominator, but sometimes it doesn't have to. But what you must always remember is that the denominator must contain x. It must have an x in there, otherwise it won't be classified as a rational function. Okay, so generally the following would be the format of how you would write down the rational functions: p of x over q of x, like this. All right, so moving on to the next part, I want you guys to write down this word and highlight this, or if you could just write it in your notes. It's called vertical asymptotes. A vertical asymptote is an imaginary line, and it's obviously going in a vertical up and down motion. But the word asymptote always represents sort of like a dashed lines here, if you will, like on the visual representation on the right-hand side. It's a line that the graph approaches to, but never touches. So as you can see, this blue line right here going down like this, it will slowly approach the asymptote, but it will never cross it, or it will never touch it. Nor this graph right here, it will go up steadily. It will kind of approach that asymptote, but it will never cross that line. So x equals 3 is a vertical asymptote. Why? Because for this particular equation, this example, x over x minus 3, how do we determine a vertical asymptote? You just simply have to take a look at the denominator and go, what x could make this 0? That is just the question you want to ask yourself. So you want to set the denominator equal to 0 and essentially solve for it. That's all you actually have to do. And then you will find yourself a very nice vertical asymptote, and you'll be on your way. So let's try a couple of more of these examples. Let's say that I give you a question like number 16. So for 16, I have a rational function, 2 over x squared minus 5x plus 6. And the question is, determine the vertical asymptotes for these questions. And so if I have a question like this, the first thing to do is to find a vertical asymptote, I'm going to abbreviate it as VA. You must set denominator equal to 0. So I said x squared minus 5x plus 6 is equal to 0. But then I'm not done because I need to solve for the values of x, right? If you notice, this is a quadratic and you can factor. So you will have x minus 3, x minus 2 is equal to 0. So you have x equals 3 and x equals 2, and these two will be called your vertical asymptotes. So in a way, you're still doing these same old school stuff related to quadratic, solving for zeros and such, but these will be represented as vertical asymptotes. Can you have multiple vertical asymptotes? Why, sure you can, but do not expect more than 2 to appear on any of your assignments. It's usually going to be 1 because I'm going to keep it simple for rational functions here. I think that should wrap up for the vertical asymptotes in terms of going over the examples. Now let's give it a try for 17. Please try this on your own. Pause the video for right now and try this on your own and try to get the vertical asymptotes for me. There should be 2. Okay, so hopefully you have set this equal to 0, and then you have just factored it very nicely. X equals -4, X equals 2. So there should be 2 vertical asymptotes like this, and that should be it. All right, so that seems just a bit too easy, right? So now I want to talk to you guys about point of discontinuity. We are actually going to skip this. We are actually going to go right into what we call horizontal asymptotes, and we will be actually be able to sketch these rational functions, and that's the goal for today. So horizontal asymptotes and vertical asymptotes, what I want you to remember is write down in these notes here. Vertical asymptotes always starts with x is equal to, just like the ones we have solved from the previous part. The horizontal asymptote starts with y is equal to, because a y is equal to, let's say, a number, for example, like 1. When you sketch that, it will look something like this. So it's a line that goes through y is equal to 1. So it will make it horizontal. Fun fact, horizontal and y, they're kind of the opposite. Horizontal goes left and right. Y is actually up and down. So always associate the opposite wording with the letter when you're writing down the asymptotes. That's just a little bit of a tip I can provide for you. Next slide. So horizontal asymptotes, we are not going to do this last condition, by the way. It's called oblique asymptotes, and I think it goes beyond the Algebra 2 curriculum. So you need to actually get these two things down. Once you have these two written down in your notes and understand how to apply them, then horizontal asymptotes will just be a breeze. Okay, so what this means is we are going to first find out the horizontal asymptotes by looking at the first condition. Now, the first condition, the n and m always comes from the degree. Well, what is a degree? A degree is the exponent of the leading term. Remember when we were doing the polynomial and we always consider the rest of them, not worth it because we do not want to take a look at all the rest, because the leading term basically tells you the shape of the graph or how it's going to be. Well, it's pretty much the same deal here. Horizontal asymptote simply means what happens when x is a very, very large number and when x is a very, very large negative number, because you're going all the way to left and right. How is the graph going to be shaped towards the n direction? When you have a numerator's degree be less than the denominator's degree, you will always say that the horizontal asymptote is y is equal to 0. That's it. So for example, let's say I give you x over x squared. X squared over x cubed, 1 over x. All of these components that contains the denominator's degree to be bigger than the numerator's degree, you will always have y is equal to 0 for your asymptote. Well, why is that? Well, because you are plugging in x as a very, very big number. If x is like, let's say, infinity, you plug infinity here. That's infinity squared over infinity. Infinity compared to infinity squared, well, this is such a large number that if you take a small number divided by a very, very big number, so for example, like 1 divided by 10 billion, that approximates to like 0.00000 and so on, this will approximately be 0 regardless, no matter what you do. So that's why you say that it's never going to exactly equal 0. So it slowly approaches 0, but it's never going to touch it because it's never going to equal 0. Like I said, it's going to approach it. So that's why y is equal to 0 will be your horizontal asymptote when the degree for the numerator is less than the degree in the denominator. When degrees are equal to each other, you are actually simply going to take the ratio of the coefficients themselves. So for instance, let's say I give you 2x over x squared plus 1. So this is just an example. Now the degree in the denominator, that should be 2x squared. Now the degree at the top, the leading term will be 2x squared, and the leading term will be x squared. The plus 1, you don't even take a look at because it's not part of your leading term. So 2x squared over x squared. Now, since the degree from the top and bottom is the same, you can kind of think of them as like canceling them out all together, and you actually end up with a 2. So you look at the ratio of 2 to 1, and voila, we're done. So those two conditions are the only horizontal asymptotes, like how you could find them. And I want you to keep that in mind when we're doing the next couple of problems here. Okay, so this is for your notes. And for today's homework, I'm going to give you a lot of these guys here. So general rational function transformations, These are the graphs that you will get to see for today. And you can use Desmos to kind of help you to sketch this on your own. If I have x minus h plus k and a over that, this is a rational function transformations. You can probably assume what h and k is all about. I would like for you to write this in your notes, and I would like for you to write down the following. H will always be your vertical asymptotes. K would be your horizontal asymptote. And A should be an integer value. Integer being 1, 2, 3, 4, like whole numbers, like that. All right, so I'm gonna provide you guys with a question, and then we are going to do one independent practice from the video, and then I'll assign you homework questions based on this. So your homework questions will look a lot like this. So it says graph each function, and it's to state the domain and range of each of these functions here. So how do I sketch a function that looks like this? Well, first of all, your job is to first identify for me what vertical and horizontal asymptotes are. It seems to me, vertical asymptotes, remember, it needs to start with x is equal to. So we're going to write x is equal to. And horizontal asymptote, we're going to write y is equal to. It's always what makes the denominator 0. X minus 4. The plus 2 at the end, that's your vertical shift up and down. So we are only going to take a look at x minus 4, or better yet, that's your h value from your previous formula. So we should all both agree that x equals 4 will be your vertical asymptote. Horizontal asymptote is y is equal to 2. That's how much it's been shifted up. And I want to tell you why that is. Remember, 2 over x minus 4, the leading term, the degree in the denominator is bigger. So therefore, the horizontal asymptote should be y is equal to 0. But this plus 2 essentially increases the horizontal asymptote by 2. So it goes from y is equal to 0 to y is equal to 2. And that's where this horizontal asymptote is coming into play. We are going to now apply that into our graph. So here's what you're going to do. You're going to go to 4, and then you're going to draw a vertical line down like this. You're going to draw a dashed line like this. And then you're going to go to y is equal to 2 and draw a dashed line like that. I like to call this establishing the framework, because if we do not have the asymptotes established from the first place, we cannot sketch it. When we were in the kindergarten, way back in the days, you know, we get these little like dash lines, and we write like A and B, the letters like this. So because we are in the infant stages of writing these letters, and we want to have some guidelines as to how big or how small we should make it, right? So this is essentially the same thing. These dashed lines tells you where you need to be plotting the graphs here. Okay, so then what comes next? Well, what comes next afterwards is you need to sketch the graph by using, of course, testing points. Testing points are any points that you can utilize to plug into the function, and that gives you I would like to call them tour guides. So it gives you a little guidance as to how to sketch your curve. So testing points could essentially be anything, but I like to always pick a value that is really not that much different from the vertical asymptote. I want to pick one that's on the left side of the vertical asymptote and on the right-hand side of the vertical asymptote. So a vertical asymptote is that x is equal to 4. So can I plug in x is equal to 3 and x equal to 5, the ones that are right next to it? Why, sure, I can. So I'm going to plug in x as 3. So what is the y value going to be? I'm going to plug in 5 for x, and what's the y value going to be? I'm going to erase this, and then I'm going to show you the calculations here. So when x is equal to 3, I'm going to plug 3 into the function here. So 3 minus 4 plus 2. So that's what I plugged into the equation here. 2 over 5 minus 4 plus 2. All I did was replace the x with a 5. And now what is this going to become is 3 minus 4 is negative 1. 2 divided by negative 1 is negative 2 plus 2. This actually becomes 0. 2 over 5 minus 4, that's a 2. So 2 plus 2 is a 4. So my two testing points, you definitely need 2 of these guys here, is 3, 0, which is right here, and 5, 4, which is right here. Now for rational functions, what I want you to think of it is they'll always give you what I like to call opposite boomerangs of each other. So here, if I have a point, that's essentially all you need, because you are going to sketch like this from the top, it aligns itself with the asymptote. Then it's slowly going to curve and hit this dot right here that we just found. And then it's also going to slowly start to go down and align itself with the vertical asymptote. So you have this boomerang happening in this fourth slot, like this third slot of the window. So we have a window frame, right? 1, 2, 3, 4. Those 4 spaces are where we're going to sketch. And we have essentially a boomerang shape on this bottom left corner right here. Okay, so now then what do we do with this dot? Well, align yourself the graph with the asymptote, and then you were just gonna sketch it like this. Draw yourself a little bit of arrow signs indicating the fact that it's going up and right, left and down, all the way like that. So these are like opposite boomerangs that are facing each other in this diagonal manner. That is essentially what's gonna happen for all of your homework questions for today. And so if I were to give you a little bit of a checkup here, so I'm going to sketch the function 2 over x minus 4 and then plus 2. And notice that you have these 2 boomerangs happening just like the one we sketched right here. And so if I plot the vertical asymptote x equals 4, it goes right on that blue line. That red line will never touch the blue line. It's never going to cross it. It's slowly going to approach it though. So that's the definition of asymptote. And the horizontal asymptote is, of course, y is equal to 2. And so we can see that horizontally, that red line will never go above that green line right there on the left-hand side, and it will never go below the green line on the right-hand side. So that is what rational functions are all about. Always check your answers with the Desmos when you get the opportunity to do so. We're going to do one more problem, and then we're going to wrap up for today. So there are 3 steps involved: vertical asymptote, horizontal asymptote, and what I would like to call testing points. Please make sure you plug in 2 of those. Establish your framework, sketch the graph, and check your answer using Desmos. Pause the video right now and try to do this on your own, and we're going to compare our answers together. And that should be it for today. All right, so hopefully you have all the answers. It should be x equals to -1. Horizontal asymptote should be y is equal to -4, essentially what this number is. Now the testing point 0, something, I'm going to plug in -2, a value that's left of -1. And so we can plug in those values in. So -3 over 0 plus 1 minus 4, -3, -2 plus 1 minus 4. When I do the math here, it becomes -7. When I do the math here, it becomes -1. All right, so I have all the things I need. Let's go to our graph and establish the framework first. So x equals -1, that's where my vertical asymptote would be. A horizontal asymptote would be at -4. So now I'm going to plot the coordinates 0, -7, which is right here, and -2, -1, which is up here. Now, the boomerang now happens in this direction, right? So I have a boomerang down here and I have a boomerang down here, up there. This is what the sketch is going to look like. So I really don't have to do much other than what I've just drawn here. It's really just got to align itself with the vertical and horizontal asymptote. Again, go through that point if I just draw a little bit of a better sketch like this. So that's how it should look like. Even so, the reason why it's been like swapped is because this one is a +2 over x minus 4. So it has on this and this side. This is a -3 over x plus 1. So the negative actually kind of reflects it across the x-axis or reflects it across the horizontal asymptote. So the graph that was supposed to be like this, it flips it over and it becomes, it happens here and there. And also we can check with our Desmos. Okay, I'm going to erase these 2 circles so we can see it clearly. So the equation was -3 divided by x plus 1, and move it to the right, -4. I'm going to erase this. And there we go. So we have this equation. Now the horizontal asymptote will happen at x equals -1, and horizontal asymptote is -4. Vertical asymptote is a -1. And look at that. Everything just aligns itself pretty well. You have to have the graph resembling on the Desmos. Make sure you check over your answers just for verification purposes. Okay, so thank you guys so much. This is what you're going to be working on. We'll give you 4 questions like this Take your time. This is a first day of rational functions. So I actually introduced you guys to a lot of materials. Vertical asymptotes, horizontal asymptotes, and testing point is what I would like for you to use. Work on the assignment that's provided for today, and I'll see you guys tomorrow.